Hey there, have you ever thought about how people capture images way before we had fancy smartphones, DSLRs, or even film camera? Imagine taking a picture without a lens, a sensor, or any electronics, just a box with a tiny hole. This cool little invention is called the pinhole camera. The purpose of black lining is to absorb excess light and prevent unwanted reflections that might blur the image. And it actually dates back over 2000 years. Believe it or not, thinkers like Mosey from ancient China and the legendary Aristotle from Greece were already curious about how light can make pictures through tiny holes. Later, geniuses like Alhazen and even Leonardo da Vinci played around with these optical principles, laying the foundation of modern photography. And today, you and I are going to build one right from the scratch and see the magic happens with our own eyes. So ready? Let's go. To build the pinhole camera, we will need a cardboard box, a measuring scale, a black drawing sheet, a wax paper or tracing paper, a glue, a pin, a candle and a matchstick. First, take a cardboard box to create a hollow rectangular box. Then cover the inner and the outer surfaces with a black drawing sheet to minimize internal reflections. So next, on the back end of the box, fix a wax paper screen using tape. On the front end of the box, place a black sheet and mark the diagonals of the square. At their intersection, use a pin to create a small hole at the center. This tiny hole acts as an aperture, allowing only narrow beam of light to enter the project and image onto the screen inside. Now in the dark room, light a candle and position the pinhole camera so that the pinhole faces the flame. Peek through and guess what? On the wax paper you will see the image of the candle, but plot twist, it's upside down. Mind-blowing, right? So let's understand the physics behind this experiment. It's based on a rectilinear propagation of light. Light is like a disciplined traveler. It always goes straight unless something makes it bend. Since the pinhole is small, only a few rays from each point on the object pass through and from the image. So the image formation, light rays from the top of the candle travel downward through the pinhole and appear at the bottom of the screen. Light rays from the bottom of the candle travel upward and appear at the top of the screen. This crossing of light rays results in an inverted image. So the characteristics of the image: it's inverted due to the crossing of light rays. It's real. The image is formed by actual rays converging on the screen, and it's diminished or smaller than the real candle because the light rays are coming from a bigger space but squeezing through a tiny hole. Unlike modern cameras, the pinhole itself acts as both aperture and focusing element. It restricts the amount of light entering, preventing blurring and producing a sharp image. A smaller pinhole gives a sharper image but in less light. A larger pinhole allows more light but results in a blurrier image. And there you have it, your very own homemade camera powered by nothing but a hole and a magic of physics. This experiment beautifully demonstrates the pinhole camera is a fundamental concept in optics, forming the basics of modern cameras, projectors, and even our own eyes. Understanding how light interacts with small apertures helps us appreciate the science behind the photography and vision. Remember, this simple experiment is actually the secret ancestor of all cameras we use today. Whether it's a phone camera or a space telescope, they all started here with the humble pinhole. So next time you snap a selfie, remember, you just built its great-great-great-grandparent.